Hello fellow makers and welcome back to my channel. I can assure you that the guy is completely fine, and in today's video I will show you how you can turn your 3D printer into a mimir. Okay, jokes aside, let's get started. The things you will require for making this smart plug are a 5V power supply. I am using a Raspberry Pi power adapter clone. Next, you will need an electrical junction box with a 15A socket. A Wi-Fi relay module. Any type will work as long as you can program the Wi-Fi microcontroller. Mine uses the ESP8266 module with the flash size of 1MB. Make sure you get a Wi-Fi module with at least 1MB flash memory. You will also need a USB to serial programming module. I am using the popular FTDI module. For programming the ESP01, I am using my DIY ESP01 programmer, which features a boot switch and a reset button. You can also go for any other programming module such as CH340 or CP2102. Some 16 gauge electrical wire, and finally a USB cable to connect the programming module to the computer. Now coming to the Wi-Fi module itself, it's a 5V Wi-Fi relay module. It is an active low Wi-Fi relay, which means the relay is turned on when the input signal from GPIO 0 is low. Same goes for the LED that is connected to the GPIO 2 of the ESP8266 chip. Prepare the programming module by plugging in the ESP01 in its place and FTDI module to its 6-pin connector. If you want to build one, you can watch the tutorial I made by clicking on this I button. Next, connect the FTDI module to your computer using a USB cable. To put the ESP01 in programming mode, press the programming button and then press the reset switch once. Make sure you got a COM port assigned for your programming module by opening the device manager and checking under ports. Now for flashing Tasmota, which is an open source firmware for ESP devices, you will need to download Tasmotizer. Go to the latest releases in its GitHub page and download it. Next, you will need the bin file to flash Tasmota on your ESP device. Normally, you can use the Tasmotizer itself as it comes with necessary firmware, but it is a good practice to flash explicit bin files. There are several options for you to download, including different languages, firmware size, and support for ESP32 devices. I am going to use the default tasmota.bin file for the firmware. Now open the Tasmotizer software and set it up. Start by selecting the COM port. You can select the COM port from the drop-down list, or if it is not showing up, you can click on the refresh button and it will show. Next, you have an option if you want to back up your existing firmware of ESP01 or not. Next, for selecting the image, you get 3 options that are bin file, releases, and beta stage firmware. Select the bin file option and choose your bin file. Then check the self-resetting device option if you are using a Node MCU or a Wemos, and make sure erase before flashing is checked. Then hit the Tasmotize button and it should start the flashing process. After flashing, it will ask to power cycle the device. In that case, press the programming button again to disable programming mode and press reset button to power cycle the device. Remove the ESP01 from the programming module and put it back in the Wi-Fi module. Next, for setting up the Tasmota firmware, you will need to provide temporary power of 5 volts to the module. I am using 12 volts to 5 volts buck converter for powering my Wi-Fi module. Next, open your Wi-Fi list and connect to the access point named Tasmota with a unique serial number. This will take you to a web page which asks you to select a Wi-Fi network, and if your network is not visible, then click on Scan for all Wi-Fi networks. Then select your Wi-Fi network and enter your Wi-Fi password, and finally click on the Save button. After that, you will be redirected to a new IP with Tasmota's web interface. The problem is your Wi-Fi router will most likely keep changing the IP address as most Wi-Fi routers come with DHCP service, but Klipper needs a static IP in order to communicate with the ESP device. So to prevent that, we will use the command console of the Tasmota and provide it with a static IP address. To do that, just copy and paste the commands one by one. I will provide the link to the instructions manual in the video description, so do check it out. After entering the last command, the IP address of the Tasmota device will change, so you will have to go to the new IP address to access the web interface. Next, we will configure the ESP01 as a custom smart plug. In order to do that, we need to configure a custom template and then use it for configuring the Wi-Fi module. Click on Configure Template and change the name to your liking. Next, for based on parameter, select Generic 18. The ESP01 has only two accessible GPIOs. One is GPIO 0 and the second one is GPIO 2. In my case, GPIO 0 is used for relay and it is active low triggered. So, I am selecting relay_I, which means inverted. Same goes for the GPIO 2, which is connected to the board LED, so I am selecting LED_I. Then click on Save, and the device will restart with new settings. After restart, again go to Configuration, then click on Configure Module, and select module type as what you named earlier, and hit Save button. It will again restart the device. One important thing that we need is that whenever we turn on the switch or give power to the Wi-Fi relay module, it should start the relay as on. For that, we need to configure the power on state. There are different modes available, but the default is to reload the last saved state. But we need to change it to turn on after power up, which is mode 1. So to change that, copy the power on state command and paste it in the console, type 1 and after that hit enter key. Next, go back to the main page of the web interface and click on restart. And I assure you, this is the last time we will restart the Tasmota device for setting it up. Finally, you can power cycle the Wi-Fi relay module and it should turn on as soon as it is given power. Try toggling the relay using the web interface and it should work. Next, we will configure our Klipper host and printer.cfg file, SSH into your Klipper host and do an update first by using either of these commands. After the update is done, download the G-code shell command extension by copy and pasting the command from the instruction manual and hit enter key. Next, install curl command line tool by using either of these commands. After that, reboot your Klipper host machine. Now for the printer.cfg file, you have to copy and paste some G-code macros into it. As you can see, I have included two more config files named client.cfg and client_macros.cfg. This is totally optional and my preference to keep things organized. You can completely skip this and directly paste the macros inside the printer.cfg file. Okay, so all my macros are in this config file. You will need 3 macros to do the job. The first one is the main macro that calls the other 2 macros to shut down the host first, then turn off the relay after some time. You need to change Tasmota off macro according to the IP address you gave and change the delay if you want. But changing the IP address will be enough. After that, save and restart your Klipper firmware. Now you can check if the power of printer macro works. Click on it in your Klipper interface and it should shut down the host machine first, then turn off the relay. For wiring, you can follow this schematic. For easy wiring, I will take out the PCB from the adapter. I will directly solder the output wire to the USB connector. I have used nitrile foam tape to insulate the underside of both the PCBs. I marked out the places with permanent marker where the modules will be glued so that it doesn't touch any AC wires and is still isolated from the AC wiring. Use a small piece of sandpaper to roughen up the gluing surface and glue the modules to the place. And finally do the AC wiring to your circuit. Be aware that working with mains voltage is not a joke and can lead to electrocution or death if not handled properly, so do it at your own risk. Finally, screw the top cover of the box to finish the project. You can use the power of macro with the Klipper's idle timeout feature in the printer.cfg file, but do keep in mind that the idle timeout is only triggered after the heaters are turned off. Or you can place the macro at the last of your G-code file using post-processing features in your slicer, so that the macro is called at the end of the print. Nevertheless, you can also manually call it using the macro button in your Klipper interface. Hope you learned something new today and had fun watching this video. If you liked the video, why not consider subscribing? It is free and you can back out whenever you want. So see you guys in the next one.